Celsius and Fahrenheit. Celsius and Fahrenheit are two scales used to measure temperature. Both scales are based on the freezing point and boiling point of water at sea level. The Celsius scale has 100 degrees between the 2 points. The Fahrenheit scale has 180 degrees between the freezing point and boiling point. Today, most countries use the Celsius scale to measure temperatures. The United States, however, still uses the Fahrenheit scale. Anders Celsius. So here's the Celsius scale. And here is another thermometer which uses the units of Fahrenheit. Anders Celsius. The Celsius scale is named for Anders Celsius, a Swedish astronomer. Celsius lived from 1701 to 1744. In 1742, he created a temperature scale. This scale used 0 degrees Celsius to mark water's boiling point and 100 degrees Celsius to mark its freezing point. A few years later, another scientist changed Celsius scale so that the 0 degrees Celsius was the freezing temperature and 100 degrees Celsius was the boiling temperature. Celsius' scale was originally called the centigrade scale. It was renamed in the 1940s to honor the inventor. Daniel G. Fahrenheit was the header. So here we read about the Fahrenheit scale. The Fahrenheit scale is named for German scientist Daniel G. Fahrenheit. Fahrenheit lived from 1686 to 1736. In 1714, he invented the first mercury thermometer. He invented a temperature scale to go along with it. Fahrenheit's thermometer marked normal human body's temperature as 98.6 degrees Fahrenheit. Fahrenheit thought he had found the lowest possible temperature by mixing ice and salt. He set the temperature of this mixture at 0 degrees Fahrenheit. Then he set the freezing point of water at 32 degrees Fahrenheit. He also set the boiling point of water at 212 degrees Fahrenheit. So let's take a look. So body temperature, the scale is from 0 to 100 degrees Celsius, and the Fahrenheit is looking from a different scale. Water, hot and cold. When things get hot, something interesting happens. They get bigger. Usually you can't see that the hot material is bigger. The change is small. But one place you can see that hot material is bigger is a bulb thermometer. A bulb thermometer is a small container of liquid attached to a thin tube. The small container is the bulb. The thin tube is the stem. When the bulb gets hot, the liquid expands. It gets larger. Liquid pushes farther up the stem. When the bulb gets cold, the liquid contracts. It gets smaller. Liquid pulls back into the bulb. How does that happen? It happens at a level that is invisible to our eyes. This is what scientists have figured out. Water is made of tiny particles that are too small to see. The particles are moving around all the time. They move faster when the water is hot and slower when the water is cold. Think about a pan of water. All the water particles bang into one another all the time. That keeps a little space between the particles. When the water is hot, particles bang into one another harder. Harder banging pushes the particles a little farther apart. When the particles are farther apart, the volume of the water in the pan increases. Increased volume is expansion. Now, can you explain what happens to the liquid in a bulb thermometer? Here's the particles of cold water in a pan and particles of hot water in a pan. So if you can see, the particles have more space between them in the hot water than in the cold water. So in a few days for our lab, we'll be exploring and making our own bulb thermometers. Header, float and sink. Imagine that you're having flat sunflower seeds for a snack and that they spill. The seeds fall onto gravel where they are hard to see. How could you separate this mixture of seeds and gravel? Just scoop up the seeds and gravel and drop them into a bowl of water. The pieces of rock, gravel will sink. The sunflower seeds will float. So if you take a look, we have a difference. Why do seeds float and bits of rock sink? Some might say that it is because rocks are heavier than sunflower seeds, but that wouldn't be true. Think about this. A piece of gravel on one side of the balance and a seed on the other side have the same mass. Each has a mass of exactly 0.1 gram. So if you can see, they hold the same weight, the same mass. So what makes the sunflower seed float? If we drop these two objects in water, the seed will still float and the rock will still sink. Why? Because the volumes are different. The two objects have the same mass, but the mass is more concentrated in the piece of rock. The rock is more dense than the seed. Density is the amount of mass compared to the volume. Volume is like, you can think of the space it takes up. Imagine that we can scrunch both objects into perfect spheres. The mass will be the same, but now we can compare the volumes. So if you can see the volumes, here's the rock and the sunflower seed. The rock has the same mass as the sunflower seed, but in a smaller volume. So the rock is more dense. But why does the rock sink and the seed float? Look at the same mass of water. And here's water. Compare the rock and sunflower seed spheres to an equal mass of water. The volume of water is larger than the volume of rock. So it's like it takes up more space, but smaller than the volume of the sunflower seed. The rock is more dense than the water, so it sinks. The sunflower seed is less dense than the water, so it floats. Water density. Why does warm water, form a layer on top of room temperature water? Water particles move faster when water gets hot. Particles push one another farther apart. The water expands. When water expands, the mass stays the same, but the volume increases. What happens to the density? Look at the glass of layered water. Which is hot water? Which is cold water? How do you know? Let's take a look at this. So, which layer would be? Let me take a look down here. So in this case, it would be the green. The cold in this example would be actually the red.